right, so we are going to do the review for the Geometry Unit 1 test. Woo woo! So, first we are going to find the distance between the points A and D. So because we're looking for distance, we are going to be using the distance formula. So that is going to be the square root of x2 minus x1, so 4 minus negative 8 squared plus 3 minus 4 squared. So then simplifying this, 4 minus negative 8 is 4 plus 8, so that gives us 12 squared, and then 3 minus 4 is negative 1 squared. So then 12 squared, as you probably know, is 144, and then 1 squared is 1. And even though it's a negative 1, it is a positive 1, because negative 1 times negative 1 is positive 1. Know we need to look for the nearest hundredth. So in your calculator, you will actually do square root of 145, and that gives you 12, approximately 0.041. Ooh, that was bad 4. So round to nearest hundredth, that's going to be the 4. The 1 tells us to stay, so my answer is 12.04 units. Okay. So then for number 2, we're going to find the exact distance between. Because we are looking for exact, that means we're just going to simplify the radical. So same formula, square root of 7 minus negative 11 squared plus 3 minus negative 6 squared. So then 7 minus negative 11, that becomes plus, so that is 18 squared. And then 3 minus negative 6, that also becomes a plus, so that is 9 squared. So then 18 squared is 324 plus 81, which is 9 squared. So then 324 plus 81 gives us 405. And again, because we want the exact distance, we have to break this down. So I know I can divide by 5. So this gives me 81 times 5. And then 81 is a perfect square, so that can move out. Square root of 81 is 9, so it is 9 root 5 units. Okay? So then for 3, we want to know, are these congruent to each other? So looking at our answers, since 1 is a decimal and 1 is a radical, it's a little bit harder to compare, but you can actually just compare square root of 145 to square root of 405. Those are obviously not the same numbers, so then you can say they are not congruent. So with symbols, you would have AD is not congruent to LM. And the reason why is because square root of 145 is not equal to the square root of 405. Okay? So now we want to find the coordinates of the midpoint with endpoints negative 212 and 1, negative 5. So with this one, we are going to add our x values together. So negative 2 plus 1 divided by 2 to get my x value, which is, let's see, negative 2 plus 1 is negative 1 divided by 2, and we cannot simplify that, so we just leave it as negative 1, 2. And then we add the y's together, so 12 plus negative 5 divided by 2. 12 plus negative 5 is like 12 minus minus 5, so that gives me 7 over 2. And that also cannot be simplified, so that is the y value of my midpoint. Ooh, that's 7 though. All right. So then I know that B is the midpoint of GZ. G has coordinates 4, 6, and B has coordinates negative 1, negative 3. Find the coordinates of the endpoint Z. So what I would actually say for this one is you can do it algebraically, but it may actually be slightly easier to not do it algebraically. So I will show you the setup for algebra. With algebra, you would take your endpoint, and this is the midpoint. So I would have 4 plus my unknown x value divided by 2 equals my midpoint x value. And then I would have my y value, 6 plus my unknown y value divided by 2 equals my midpoint y value, which is negative 3. And then for both of these, you would multiply both sides by 2 and then subtract the numbers that are with the variables. Now, the way to do it without the algebra is to think of it more linearly. So if you think about GBZ, G is for 6, B is -1, -3, and I know Z has some sort of numbers. So to get those numbers, to go from 4 to -1, that would require me to subtract 5. And then to go from 6 to -3, that requires me to subtract 9. So if I subtract 5 from my x value for G to get to B, then I need to subtract 5 again from B so that I can get Z. -1 minus 5 is -6. And then, because I subtracted 9 from G to get B, then I'm going to subtract 9 from B to get Z, which gives me -12. So my answer is -6, -12. And if you did this algebraically, you should still get the same answer. Tell me if you don't, though, because I can help you with that. So now we're going to graph the endpoints -2, -3, and 3, -1. So let me do -2, -3 is N, and then 3, -1 is E. And we want to use the Pythagorean theorem to find the length of NE. So Pythagorean theorem, you have to draw in your own little right triangle. And it doesn't matter if you put it on the top or if you come on the bottom like I did. Say, okay. So regardless of which way you see it, one of the legs of the right triangle is going to be 2, and the other one is going to be 1, 2, 3, 4, 5. So then for Pythagorean theorem, NE is going to be the C. So I would have 5 squared plus 2 squared equals C squared. 5 squared is 25 plus 2 squared, which is 4, gives us C squared, which gives me 29 equals C squared, and then we take the square root. Now, always look at your directions because we are rounding to the nearest 10th. So rounding to the nearest 10th tells me that I actually take the square root of 29, which gives me about 5.385. So nearest 10th tells me I'm looking at the 3. The 8 tells me to round up. So my answer is 5.4 units. Okay. So then, Pythagorean theorem again, but now this time we want exact length. So since my b is the unknown, I'm going to have 12 squared plus b squared equals 27 squared. 12 squared is 144, and 27 squared is 729. So then we subtract the 144, and we get that b squared is 585. So then we have to take the square root, but this is where we have to actually break it down. So 585. I know 585, I can at least divide by 5. So I'm going to divide by 5. That gives me the square root of 5 times 117. Now, although 117 may seem prime, 7 plus 1 plus 1 is 9. And you can divide by 9 anytime the digits add up to 9. So if I divide by 9, I find out that 117 breaks into 5 times 9 times 13. Well, now I have a perfect square of 9. The square root of 9 is 3. And then 5 and 13 are left inside. And since I can't do anything with them, I'm just going to multiply them back together. So that gives me 65. So then my answer is 3 root 65. Okay. And this is units. All right, so now we're going to determine the slope of each line. When you have horizontal and vertical lines, you want to think of hoi and vux. Hoi tells you horizontal has a 0 slope, so I know the slope of AB is 0. For CD, we can count. We have 1, 2, 3, 4 up. So we have a rise of 4 over a run of 1, 2, 3, 4, 5, 6 over 6. Now, because I went left, that would be a negative, but I can also simplify this. So 4 over 6 is actually going to be negative 2 over 3 because we divide the top and the bottom by 2. Okay? All right. So then, looking at EF, we have a rise of, let's see, 1, 2, 3, 4, 5, 6, and a run of 1, 2, 3. So that would give me rise over run, but 6 over 3 can simplify to just 2. And then for GH, again, that's where Hoy-Vux comes into play. This is the Vux part of it. A vertical line has an undefined slope. Okay. For 12, we need to use the slope formula to find the slope of IJ and KL, and then determine if the lines are parallel or perpendicular. So, slope formula is y2 minus y1 divided by x2 minus x1. By the way, as you're doing your review, you should have your formula sheet next to you because you will be able to have that on the test as well. So, for IJ, I would start, let's see, this is so we'd have 3 minus 0 over 5 minus 1. 3 minus 0 is 3, 5 minus 1 is 4. So if these are parallel, then I should get 3/4 for KL. And if they are perpendicular, then I should get negative 4/3, hopefully. So let's look at KL. We do the subtraction with the y, so 2 minus negative 1 divided by 0 minus 6. The 2 minus 1 becomes 2 plus 1. So this is 3 over negative 6, which is negative 1/2. So I realized I did not actually write my slopes on the line I was supposed to. So the slope of MJ is 3/4, and then the slope of KL is negative 1/2. So since these are not the same slope and they are not opposite reciprocals, this is going to be neither. These lines will eventually run into each other, but in the case of parallel or perpendicular, it is neither of those. Okay? So now we are going to graph. So we have PQ and RS. So with PQ, that's at 5, 1. So 1, 2, 3, 4, 5, and 1. And then negative 1, negative 1. So the line looks like that. And then for RS, we have 2, 1, and 3, negative 2. So looking at this graph, it looks like they could possibly be perpendicular, but we're not 100% sure. So you have to do the slope formula to check. So PQ is going to be negative 1 minus 1 divided by negative 1 minus 5. Okay, so negative 1 minus 1 is negative 2, and negative 1 minus 5 is negative 6. Because both of these are negative, they can now both be positive. And then we divide the top and the bottom by 2. So that gives me 1 over 3. So then, to compare, hopefully if these are actually perpendicular, RS should have a slope of negative 3 over 1, but we will see. So RS, if we start with negative 2, we have negative 2 minus 1 over 3 minus 2. And notice, because I started with the negative 2, I'm starting with the 3 on the bottom. So negative 2 minus 1 is negative 3. Ooh, it might be promising. And then 3 minus 2 is 1. So we see that with these slopes, they are opposite signs because the pink is positive, blue is negative, and they have flipped. So that tells me that these lines are perpendicular. Yay! And I've been writing very sloppily. I apologize. All right, so now for 14, we need to write the equation of the line in the given form. So you need to make sure you know the different forms. We have point slope form. And again, this is on your formula sheet, but is y minus y1 equals, not x, whoopsie, m times x minus x1. And then the slope-intercept is y equals mx plus b. So when we ask for something in point slope form, it should look like that. So with that being said, the only numbers you actually plug in for point slope form, only 3 of them. So horizontal line, that's HOI, tells me that my slope is 0. So that's the m, right? And then the x1 and the y1 come from this ordered pair. This is x1, this is y1. So when I have x minus 3 and y minus 7, and that is actually your final answer. You don't have to distribute the 0. You can just leave it because we want it in point slope form. If you distribute the 0, you're starting to turn it into slope-intercept form, which is not what we want you to do. So then we have the next one, also in point slope form. So looking at what I'm given, I have a slope of negative 8 over 5. So that's going where the m is. So negative 8 over 5. And then I have x1, y1 for my ordered pair. So I have 1 and then minus 5. But since it's y minus negative 5, that will actually take over and then just become y plus 5. So we have y plus 5 equals negative 8 over 5 times x minus 1. Okay, so then last but not least, we want a line through the points 2, negative 3 and negative 2, 3 in slope-intercept form. Is y equals mx plus b. So with that being said, we need our slope and we need our y-intercept. So starting with the slope, we're going to have 3 minus negative 3 divided by negative 2 minus 2. Negative 3 minus 3 becomes a positive, so I have 6 over, and then negative 2 minus 2 is 4. So then we can divide the top and the bottom by 2, so that becomes 3 over negative 2. So that means in this formula, I know I'm going to have y equals negative 3 over 2x, but now I need my b. So in order to solve for your b, what you're going to do is you are going to plug in one of your points for x and y and then solve for b. So if I start with my slope, and let's say I want to use 2, 3, I'm going to plug in the 2 because it was the x value there, and I'm going to have negative 3 over 2 times 2, the x, plus b. And then over on the right, because it's the y, you're going to put the y value, negative 3. So then when you multiply these together, the 2's just cancel each other out, and you are left with negative 3 equals negative 3 plus b. To get the b by itself, we just have to add 3, which in this case, b is 0. So you can write it as negative 3 over 2x plus 0, but ultimately, all you have to write is y equals negative 3 over 2x, and that is it. Okay? So for 17 and 18, we have to graph. So when it's in point slope form, just come up with your point and identify your slope. So here, my point, it's opposite. So even though it looks like a positive 1 with the x, it's actually going to be negative 1. And even though it looks like a positive 3 with the y, it's going to be negative 3. And then my slope is 3 over 4. So then I plot the point, negative 1, negative 3. And then I count rise over run. Rise up 3, 1, 2, 3, and run 4. 1, 2, 3, 4. And then you connect your dots. Okay? So then for slope-intercept form, you're given all the information you need. This 2 is your y-intercept. So you come up and plot 2 on your y-axis, and then your slope is negative 4 over 3. So negative 4/3 tells us to go down 4, 1, 2, 3, 4, and run 3, 1, 2, 3. If you were tempted to go to the left when you were counting that, just remember that we already did the negative direction when we counted down. So if we go left, we're actually going to make the slope positive on accident instead of negative. Okay, so that's graphing. Now we need to put each equation into slope-intercept form to help us determine if the lines are parallel, intersecting, perpendicular, or coinciding. What I will say with this is that I don't particularly care if it's in slope-intercept form or not, as long as you can compare it and tell me what it is. But for the sake of following directions, I will put it into slope-intercept form. So I would subtract x first, which gives me negative 5y equals negative x. And then I would divide by negative 5, which gives me y equals x over 5, or 1/5 x. So then with this one, I would have y plus 1. I would distribute that 1/5. So it's 1/5 x plus 1/5 times 5 is 1, because the 5's cancel. 1 over 5 times 5 over 1, boop, boop, cancel that. So then, because we're solving for x, or sorry, solving for y, I'm going to subtract the 1, and I get y equals 1/5 x. 1 minus 1 is 0. So even though in the blue it's not written as 1 over 5x, it really is 1 over 5x. So these ones are the same exact line. So since they are the same line, they are coinciding. Oh goodness. Oh goodness. And you do not have to actually write same line underneath, but I find it helps people keep track of why they're doing what they're doing. So for slope-intercept form, I would subtract the 2. So then I have 2y equals x minus 2. And then I would divide everything by 2 to get me y equals 1/2 x minus 1. So then looking at the next one, we want to solve for y. I would add the 1, which gives me 1/2 x plus 1 equals y. Well, you can notice the difference in these is that this is a negative 1 and this is a positive 1, which is totally fine. But their slopes are the same, and because their slopes are the same, we know they are parallel. Okay? So then, last but not least, 4 times x minus 3, you distribute. So that becomes y equals 4x minus 12. And then the other equation's already in slope-intercept form. So looking at this, I don't care about the y-intercepts, but I do notice that my slopes are opposite signs and they're flipped. So because it's opposite reciprocals, this is perpendicular. Okay. So for 22, we want to graph the line x equals negative 4. Because it is an x equals, that is vux, which tells me it's an undefined slope, and it's a vertical line. So at negative 4 on the x-axis, I'm going to draw a vertical line, and my slope is undefined. Okay, so then for y equals negative 2, that's hoy. The slope is 0, and it's horizontal. So at negative 2 on the y-axis, we have a horizontal line. Okay? All right, so now getting into areas, we have a parallelogram. Area of a parallelogram is A equals base times height. So in this case, area is 8 times 6, and 8 times 6 is 48. And so that means that my area is 48, meters, not centimeters, meters squared. Don't forget your units. So now we have another parallelogram. So it's still A equals base times height. But I know that my area is 15 and I want to try and find my base. So I plug in 15 where the A was. I don't know my base, but I do know my height is 5. So that means I will divide by 5 so that I get B equals 3. So my base is 3 inches. Okay, and I know it's not inches squared because I'm looking for my base, not the area. So then trapezoids, they have a slightly longer formula, but it is your bases added together times your height divided by 2. So given that I have all of this information, we are going to find this area by plugging in what we know. So area is 36 plus 27 times 18 divided by 2. So on your handy-dandy calculators, 36 plus 27 gives you 63. 63 times 18 gives you 1,134 divided by 2. And when you divide that by 2, you get 567. So 567 millimeters squared. So now for 26b, I want to find the height of the trapezoid. So I know that my area is 144, so I'm still going to use the same formula, bases added together times the height divided by 2. So plugging in what we know, the area is 144. The base 1 would be 12 plus 24. I don't know my height, but I can divide by 2. So to solve this, I would multiply by 2, and actually I'll change the color. When I multiply by 2, it just cancels out that divided by 2. So then 144 times 2 is 288. And 12 plus 24, you can also do, that's 36. So this is 36H. So then I'm going to divide by 36 to get that my height is 8. So that is 8 yards. Okay? All right, so now I want to find the area of the kite. Area formula for the kite is your diagonals divided by 2. So in this case, I'm going to have 12 times 5 divided by 2. 12 times 5 is 60, and divided by 2 would give me 30 kilometers squared. Okay? Next one, 28, we want to find the area of the rhombus. So area formula for rhombus is the same as a kite. It is your diagonals times each other divided by 2. Now, we know area and we know D1, so we are going to plug in 72 and 16, and we're going to leave that D2 divided by 2. So to solve this, choose some different colors, we'll multiply by 2 this time to cancel out the one on the right. 72 times 2 gives me 144. And then I divide by 16. So 144 divided by 16 gives me 9. And again, this is just straight yards because it's not the area. So now with 29 and 30. For 29, we want to find the area of circle V. So area for a circle, oh, I guess it's over here, is pi r squared, and circumference is 2 pi r, or a pi d, depending on which one you're thinking of. So using area of circle V, that would be pi times my radius, which is 25, squared. 25 squared is 625 pi. And because they say give it in terms of pi, I'm just going to leave my answer in terms of pi, 625 pi meters squared. And you're done. So then for 30, we are going to have to do, let's do green now, why not? So for 30, we have circumference is 2 pi r. Ooh, but they actually give me the diameter. So it would actually be better in this case to just use pi d. My diameter is 1200, so that gives me 1200 pi. So then, because it's in terms of pi, my answer is 1200 pi miles. And this one is not squared because circumference is not squared. It's just the distance around. It's like perimeter. So in 31, I have a circle whose circumference is 12 pi, and I need to find the area. So if you use the circumference is 2 pi r formula, you plug in 12 pi for c, and you solve for r. So I would have to divide by 2 pi here. And when I do that, I get 12 divided by 2, which is 6. So once I know my radius is 6, I can plug into the area formula. Area is pi r squared, which is 6 squared. So then 6 squared is 36 pi. And this is area again, so this is units squared. Okay. Now on to the fun ones. We have the polygons, and those ones always cause people issues. But area of a polygon is your apothem times your perimeter divided by 2. So looking at this, I have my apothem, I have my perimeter. Awesome. Makes my life simple. So my perimeter in this case, because I have 1, 2, 3, 4, 5, 6 sides, would be 20 times 6, because I would do 20 plus 20 plus 20 plus 20, all the way up to 620s. So that gives me a perimeter of 120. So I plug in what I know. My apothem is 18 because it goes from the center to the middle of one side. And then I'm going to multiply by my perimeter, which we found just now to be 120. And then we divide by 2. 18 times 120 gives me 2,160. And when I divide by 2, I get 1,080. So because this is area, this is going to be inches squared. Okay. So then for 33, and 34, those are the ones we have to do extra work on. So with this polygon, we're going to have to actually solve because we know that our sides are 10, but I don't actually have my apothem because my apothem is the blue line I just drew. So with the one I just drew, I know that the side I went to is cut in half because that is the definition of an apothem. So because my area formula is apothem times perimeter, it's kind of important that I know what it is. So in this case, I can tell you my perimeter right now. It's 5-sided. Each side is 10, so it's 5 times 10. So I know my perimeter is 50. But what I don't know is my apothem. So I'm going to just kind of write in some of this just so I don't change colors later. But in order to find my apothem, I have a nice little right triangle in there. And really, my apothem is like my a. So using Pythagorean theorem, I would have a squared plus 5 squared equals 6 squared. A squared we can't do anything with. 5 squared is 25, and 6 squared is 36. So then I subtract 25 from 36, which gives me 11. 11. And then I have to take the square root. Now, those of you with a graphing calculator, you can do this without actually rounding until the very, very end. If you do not have a graphing calculator, then you want to go out probably 3 or 4 decimal places just to have a few extras to help with the rounding. But I get that my apothem is 3.3166. Now, I will tell you, on my calculator, I am still multiplying by the full number, okay? Which I don't have enough space to write all 4 digits. But all I'm doing on my calculator with the graphing calculator is once I put in square root of 11, it gave me the decimal. Then without hitting anything, without adding any numbers, I just hit times, and it should say A and S with little star, times 50 gives me about 165. 165.83, and again, the ... is that I'm not rounding yet. But then on the calculator, divided by 2, I still have not rounded at all, but that gives me 82.9156, blah, blah, blah. So now that I have that, and because I want nearest tenth, I waited until the last step to round, because I just kept my calculator going. If I'm rounding to the nearest tenth, that 1 tells me to stay. So my answer is 82.9 meters squared. If your answer is close to it, then chances are you probably did it right. It's just some rounding issues. Not that the issues will take points off, but it's just so that you are aware that you might get slightly different answers if you actually round before your final step, okay? So for 34, it's still going to be the same formula. It's still the apothem times the perimeter divided by 2. But this time, I am not given a side length. I am given my apothem. So I'm actually just going to draw it in. My apothem in this case is 4 meters. But I need to know what the heck is my full side length. Now, the problem with this is that when you do Pythagorean theorem, it's only going to give you the blue highlighted part I just did. So we are going to do it, but then when we get to the end, we're going to have to multiply by 2 to get the full gray side. So we would have 4 squared plus b squared equals 6 squared. Ooh, did not want that to happen. Stop that. So then 4 squared is 16 plus b squared equals 36. When you subtract 16, you get that b squared equals 20. So take the square root, and we are rounding to the nearest tenth, square root of 20. And again, with your stuff, you want to try and avoid rounding when you can. But we get that the base is about 4.47 blah, blah, blah. But because that is only the blue highlighted part and I need my full side, I'm going to multiply that by 2. So then when I multiply that by 2, that gives me about 8.944, and again, it goes on and on. So because this is going to relate to my perimeter, I have 5 sides that are about 8.944. So I'm going to multiply by my number of sides to get my perimeter. And again, on my graphing calculator, I have not rounded at all. So that gives me 44.721. So then we are going to finish this, and plug in 4 times 44.721, divided by 2. I have someone standing at my door, so 1 second. Divide by 2, and that gives us an area of 89.44. So rounding to the nearest tenth, that would be 89.4. And that is meters squared. These points, so we have -1, -2, 2, 1, 2, 3, and -1, 0. Oh man, I cannot draw these lines straight. Oop. Oh my goodness, I don't know what my problem is. It's okay, I guess. All right, I tried. Okay, so to find the exact perimeter, this is a polygon or a parallelogram, it looks like, which both of these sides are 2 and 2, and then we know that they are actually parallel to each other. So then looking at the other sides, we have 1, 2, 3, a rise of 3 and a run of 3, and a rise of 3, run of 3 again. So because both of these sides are the same, I just have to remember to multiply it by 2. So 3 squared plus 3 squared equals c squared, so that we can find the side length. So that gives me 9 plus 9, which is 18. And the square root of 18 breaks into 9 times 2. Oops. So then 9 is my perfect square. It gets to move out. Square root of 9 is 3, and we still have the square root of 2. So then for this perimeter, we're going to have 2 plus 2 from those sides, plus 3 root 2 from what we just had, and we have 2 of those sides. So we have to do 2 of them. So 2 plus 2 is 4, and then 3 plus 3, because these radicals are the same, is 6 root 2. And this is units. Okay. So then for 36, we plot it real quick. -2, 3, 3, 1, -2, -1, and -3, 1. All right, so since this is a kite, looking at this, we have a rise of 2, run of 1, down by 2, run of 1. So these two are going to be the same. And then on this side, we have 1, 2, 3, 4, 5, and 1, 2. And on this same side, 1, 2, 3, 4, 5, and 2. So my green and my pinks are going to be the same. So I only need to do Pythagorean theorem twice. So I have 1 squared plus 2 squared equals c squared. That gives me 1 plus 4, which is 5. And 5, we can't take the square root of, so we just leave it as the square root of 5. And then for the other one, we would have 5 squared plus 2 squared equals c squared. 5 squared is 25, 2 squared is 4, and when we add them together, we get 29. And when we take the square root of 29, can't do anything with it. So then, because we are looking for perimeter, we're going to add all these together. So I would have square root of 5 plus square root of 5 plus square root of 29 plus square root of 29. Oops, 29. So because I have 1 root 5 plus 1 root 5, that gives me 2 root 5 plus 1 root 29 plus 1 root 29 gives me 2 root 29 units. And that is the conclusion of your review. So if you have any further questions, comment below, subscribe to the channel so that you always get notifications when I make videos, and good luck on your test.